Question 19. The forward reaction in this equilibrium is endothermic. So that means when it goes left to right, it goes in this direction, left to right. It's endothermic, so it takes in heat. So COCl2 turned into CO, and Cl2 takes in heat in that direction. In the other direction, it must be exothermic and give out heat. Let's read through the statements and work out which one's correct. If the total pressure is increased at a constant temperature, the proportion of COCl2 in the equilibrium mixture will increase. The total pressure, what the total pressure does is if you increase the pressure, it, by Le Chatelier's principle, will try and lower the pressure by lowering the volume, and it'll try and take, say for example, 2 molecules here on the right down into 1 molecule here on the left. So increasing the pressure, Le Chatelier's principle, lower the pressure by taking 2 moles of gas on the right down into 1. So the equilibrium would shift to the left-hand side. The proportion of COCl2 in the equilibrium mixture, the amount of this would increase. So A is wrong. The use of a catalyst will increase the proportion of COCl2 in the equilibrium mixture. No, it doesn't. A catalyst just increases the speed of the forward and the backward directions and increases the speed at which equilibrium is reached. It doesn't actually shift the position of equilibrium to the left or to the right. So B is wrong. Reducing the equilibrium concentration of CO will increase the value of the equilibrium constant. No, the only thing that alters the value of an equilibrium constant is temperature. So nothing else will do that. So the answer must be D. Raising the temperature will increase the value of the equilibrium constant. So let's think about that. Temperature could increase the value of the equilibrium constant. Yes, it could, so that's very much a possibility. Temperature is the only thing that can alter the value of an equilibrium constant. Increasing the temperature will it's endothermic going left to right, so it will take in heat if you go left to right. If I increase the temperature, by Le Chatelier's principle, it will try and lower the temperature of the surroundings. It can lower the temperature of the surroundings by using this reaction to take in some of the heat, and it will shift to the right hand side. If it shifts to the right hand side, the equilibrium constant is the concentrations of the chemicals on the right hand side, the products, divided by the concentration of the reactants on the left. So if I'm getting more products, yes, the equilibrium constant is increasing. Yes, the answer is answer D. Which of these is not a redox reaction? So redox reaction means that something's reduced and something's oxidized. So let's find something in here where there's no reduction or oxidation, because something must be oxidized and something must be reduced. Let's have a look at the copper here. Oxygen's in -2 oxidation state, no charge left over, so -2. What number multiplied by 2 will cancel out a -2? That's a +1. So the copper's in +1, because +1 and another +1 is +2 to balance out the -2 of the oxygen in -2 oxidation state. It's in -2 oxidation state because it's in group 6 and gains 2 electrons and becomes 2 minus iron. Copper here, sulfur's in group 6 +6, and oxygen, as we've said, is -2. 4 minus 2 is a -8. +6 minus 8 leaves -2 from the S and the 4 O's, -2 from the sulfate. You might know that sulfate ion is SO4 2 minus. Anyway, 2 minus from the SO4, so the copper must be in +2. So it's gone from +1 up to +2. It's been oxidized. There's oxidation going on there, and there must be probably some reduction as well. But certainly this, I've found some evidence of oxidation or reduction in A. So let's see in B. MgO. Mg must be in +2. O is 2 minus, so that must be +2. Cl is in group 7, gains 1 electron, -1 oxidation state, 2 Cl's, 2 minus 1's, Mg is in +2. Mg has stayed at +2 throughout, so that's evidence of no reduction or oxidation taking place. Your answer is B. Let's just check this out then. So something else here. So we've got SnCl2. Cl is in -1 oxidation state, no charge overall, so Sn is in +2. 4 1 minuses for the Cl's in -1 oxidation state. The Sn is in +4. It's gone from +2 up to +4. It's been oxidized. MnO2, O's in -2 oxidation states, that's -4. The Mn is in +4 here. Cl -2 for the 2 1 minuses on the Cl, minus 2, plus 2, the M ends in plus 2 to cancel out the minus 1 and the minus 1 on the Cls. So it's gone from plus 4 down to plus 2. That's been reduced. So your answer is B. Which has the highest first ionization energy? They're all in the same period. So Na, Al, Si and Cl are all in period 3. So they've all got the same number of shells. They've all got 3 shells. And as you go left to right across the, so they've all got the same amount of shielding. As you go left to right across the periodic table, across that period, they're going to have more and more protons and a greater and greater nuclear charge. So as you get a greater and greater nuclear charge, it needs more energy to remove a mole of electrons from a mole of gaseous atoms. So your answer will be C, the one furthest to the right with the greatest nuclear charge. Your answer is D.